Many people felt and heard the powerful blast of air. Many were injured. A hole in an ice-covered lake shows the size of a fragment that didn't burn up in the atmosphere. Even small asteroids can be extremely dangerous. So what are we doing to protect ourselves? And what exactly is an asteroid? When our solar system formed 4.5 billion years ago, some fragments that didn't become part of a planet or moon were left to drift in orbit around the sun. Many of these drifters are asteroids. Some are mostly solid rock, others are rubble and dust, and some have evidence of water beneath their surface, which makes us wonder, did asteroids smash into Earth, bringing the water that kick-started evolution? They range in size from pebbles to huge rocks, a quarter the size of our moon. We found most of the larger ones. None of these appear to be on a collision course with Earth, but it's the smaller asteroids that threaten us most. Shorter in length than a football field, they are very difficult to find. But we are looking. Asteroid hunters search the skies for any moving speck of light. Observations are not only from telescopes on Earth, but also from space, to give us a clearer and wider view. When hunters locate an asteroid, it's represented as a dot inside a three-dimensional model to track it over time. This tells us if it will come close enough to Earth to be of greater interest. We've been tracking asteroids for decades. Today we know there are many millions. Most orbit the Sun in the asteroid belt between Mars and Jupiter, but not all of them. Sometimes an asteroid's orbit brings it close to this giant gas giant, and Jupiter's powerful gravity sucks it in and kicks it out of the belt. Like a giant slingshot. And occasionally, asteroids arrive, propelling chunks of rock in all directions. Suppose we discover one on a collision course with us. Hopefully we will have spotted it early and it will be many years away, giving us time to figure out how best to tackle it. But to truly understand an asteroid, we need to take a closer look. Unmanned machines will make the journey, gathering detailed information, size, shape, density, composition, internal structure, rotation, and gravity. This will inform us what to do next. There are several ideas on the drawing board. Here are 3 of them. Designed to target the asteroid for a controlled, well-timed wallop is an impactor. This will change the asteroid's speed and orbital path so that it will miss Earth. The more time we have, the smaller the punch required. If we had at least a decade's warning, we'd fly a large spacecraft near the asteroid. The small gravitational pull from the craft would be enough to draw off its current course, just enough to miss the Earth. And if all else fails, or if time is against us, a risky approach would be to blow it up. Risky because exploding the asteroid would likely shatter it into many pieces that could hit the Earth. But why are you here? Not to defend the Earth from a possible asteroid impact, as machines will likely do that job, not humans. If you are here, it's because you're part of a much bigger adventure. We have an instinctive curiosity to explore other worlds. This led us to the moon. Today, it spurs us to cross the solar system. In our quest to find life beyond our planet, we explore worlds that we know or suspect contain water. We're very interested in the ice-covered poles of Mars and its tiny moons, Phobos and Deimos. Another great